Question number 11 is the sequences and series question, which says we've got a competitor running a 20k race. She runs the first 4 kilometres at a steady pace of 6 minutes per kilometre. So she does 4 lots of 6 for the first 4k. Then she begins to slow down. And what she estimates will happen is that she increases the time it takes for her to complete the next mile is an extra 5% compared to the last one. So the next time, the next kilometre that she completes, the 5th one, is going to be 6 times, well, 6 with an extra 5% added on. And as a multiplier, that's going to be 1.05. That, if you work that out, 1, 2, 3, 4, and then 6 times 1.05 is 6.3. But then the next kilometre, the 6th kilometre that she runs, she's going to run 5% slower than this one. So we need to add on 5% to this. So 6.3 times 1.05, which is 6.615. So the total that she runs is 4 6s plus the 6.3 plus 6.615. And if we add all that up, we're going to have 24 plus 6.3 plus 6.615, which comes to 36 point, I'm not sure why I put 2 decimal places there. That comes to 36.915 minutes, which is 36 minutes, and 0.915 is 54.9 seconds, so 55 seconds, which is what they had. Okay, part B says show that her estimated time in kilometres to run the rth kilometre, as long as r is bigger than 5 but less than or equal to 20, is 6 times 1.05 to the power of r minus 4. And if we go back to the previous question, I'd written down for the 5th kilometre she ran this, which I simplified to 6.3, but then I times this by 1.05 again. So if we were to do that all in one go, we'd be timesing this by 1.05 and then timesing it again by 1.05, which is the same as timesing by obviously 1.05 squared. And that's for the, if we count up, 3, 4, 5, 6th kilometre. Power of 2 and the 6th kilometre, so there's a difference of 4. Between the kilometre and the power, because of the first 4 kilometres were all run at the same pace. So in general, for r being between 5 and 20, it's going to be 6 times 1.05 to the power of the kilometre number that she's on, but minus 4. Which is what they've got here. Now I know I've just kind of copied out what the answer is, but I'm not really sure how else we're meant to show that for 1 mark, other than to show that there's explain what I've done here, or other than kind of writing out it will be this for the 6th, it will be this for the 7th, it will be this for the 8th, and then so you've kind of got a little bit more evidence that the power and the value is a difference of 4. I don't actually know how else you meant to show that for just 1 mark. I'd rather it wasn't a show that question, I'd rather they just ask for a formula. To estimate the total time then, we've got this equation now, but what I would rather do is kind of separate this as a new sequence. This is a geometric sequence. They've run 4 kilometres already, which means they've got 16 kilometres to go. So if we treat this as a new sequence, with the first term being 6 times 1.05, or 6.3, remember we worked that out to be, and the common ratio to be 1.05, that's what we're multiplying by, and then just working out S16. And we've got the formula for the sum of a geometric sequence in our formula booklets. It's a times 1 minus r to the power of n over 1 minus r. N is going to be 16, so we've got 6.3 times 1 minus 1.05 to the power of 16 over 1 minus 1.05. That comes out at 149.04. And then we need to add on, remember, we need to add on the 24 when she was running at the consistent speed. So total time is that plus 24 minutes. So that's 173 minutes. And it wants it in minutes and seconds. So if I take off the 173 and times by 60, that is 173 minutes and 3 seconds, 2.53, so 3 seconds.